Hello, we are going to start see another example for t-test, testing of hypothesis. Previously we have covered large samples for testing 1 mean, 2 means, 1 proportion, 2 proportions. Now we are going to see hypothesis testing for small samples. Previously it has been discussed that if the sample size is less than 30, we assume it to be a small sample, because as the sample size tends to go to infinity, the t distribution becomes normal distribution. So that is the reason for small samples we use t-test. You could use t-test for large samples also, but in that case it tends to become normal distribution. The values are more or less similar to the normal distribution values. So that is the reason for small samples we take t-test. And one more important reason for using t-test is the standard deviation of the population is not given. If you remember, in the formula for test statistic, to calculate the test statistic in the normal distribution form means we need sigma, the standard deviation of the population. But in situations where the standard deviation is unknown, but you can calculate the standard deviation of the sample based on the observations provided, then you could go for t-test. Alright, now look at the question. We have a sample of 25 people. The length of time to prepare dinner is recorded. So 25 people's dinner time has been recorded, and the observation is given in terms of raw data like this. And they're asking, is there any evidence that the population mean time to prepare dinner is less than 48 minutes? Okay, and use the level of significance as 0.05. Now raw data is given to us. They have given 25 random dinner preparation times, and asking us to find out if there is any evidence to prepare evidence that the mean population to prepare dinner time is less than 48 minutes. So in this case, the first step is to write null hypothesis and alternate hypothesis, right? So null hypothesis is going to be mu is greater than or equal to hypothesis. We want to disprove this, and we want to prove mu is less than 48. Okay, so the population mean time is less than 48. Okay, so this, you write the null hypothesis and alternative hypothesis like this, and because the symbol here in the alternate hypothesis is less than, the test is one tail test, and you specifically will be using left tail test. Second step is to find the level of significance. In the question they have given us to assume it to be 0.05, that is 5% level of significance. So we are considering it to be 0.05. Step 3 is to calculate the test statistic. The formula for test statistic is equals to x bar minus mu naught by S1 by square root of n. So x bar. So in this given raw data, how will you calculate x bar? Mean of data, sum of observations by number of observations. So you add all the numbers by 25. You have 25 observations. Okay, then you get 45.628. The mean time is 45.628 minutes. Now for the same raw data we have discussed in unit 1 to calculate the standard deviation also. If you have any doubts, please refer your notes. You will find standard deviation calculation for raw data. So use the same, I have used the same formula to calculate the standard deviation, that is square root of xi minus x bar whole square by n. So for each observation you find the deviation from the mean, that is, this is xi minus mean is 45.682 whole square. So, and you sum it and take all the summation of all the values, put it under a square root and divide it by n. You will get 6.816. Okay, now substituting these values in the test statistic, we get 45.628 minus 48 by 6.816 by square root of 25, which is equals to minus 1.7402. Okay, now step 4 is to find out the critical value. Critical value is nothing but the tabulated value. Here there is a slight difference. In the z test you just have to find the area. Based on the area you were getting your critical values, but in the t-test you will need degrees of freedom. Now what is degrees of freedom? Degrees of freedom degrees of freedom, the number of independent observations which make up a statistic is known as degrees of freedom. It refers to the number of values involved in the calculations that have freedom to vary. Now, in this particular problem, we have 25 values, okay, and we are trying to calculate the degrees of freedom for the formula n minus 1. For t-test, the formula for degrees of freedom is n minus 1. N is 25 here, minus 1, which is equals to 24. So degrees of freedom for this data is 24. That means there is a chance of variation in 25 dimensions for the observations. We are giving 25 chances of variations for the variables, for the data, for the observations. Okay, now t tabulated value at 24 degrees of freedom at 5% level of significance, and it is a left tail test. Okay, how do we check this? I have already sent a PDF of this table in the WhatsApp group. Please refer when you are looking at this video. And the applications of t-test and the properties of t-test have also been shared. Please go through the PDFs before and then start solving this question. So if you look at this particular table, the level of significance for two tail test is given here, and level of significance for one tail test is given here. And if this is left tail test, you look towards the degrees of freedom towards left side, and if it's right tail test, you look towards the right side. Okay, now our question being a left tail test, the degrees of freedom that we are looking for is left hand side 24. So here it is 24 is here, and the level of significance for one tail test which we are looking is at 0.05, which is here. So the value is 1.711, and because it is towards the left hand side, we put a negative sign for our convenience. So here if you see, this is minus 1.711, this area is the rejection region and this area is the acceptance region. Okay, now the test statistic is minus 1.7402, which is lesser than minus 1.711. On a negative scale, the value is lesser, so it is falling in the rejection region. Hence, because it is falling in the rejection region, we reject null hypothesis and accept alternate hypothesis H1, which is mu less than or equal to 48. Okay, hence we are accepting this one and we are rejecting this. Okay, that is how you solve t-test. It is the procedure for testing of hypothesis. The 5 steps which we use are the same, but there is a slight difference here. The formula for test statistic changes, and the way we check the tabulated value, we are using degrees of freedom. Here in normal distribution there was no degrees of freedom, it was based on area. Here we are using degrees of freedom. And if you have any questions, please post it in the group. We'll try and resolve it. Thank you.